Okay, let's do the rest. So we were over here on number 4. And let's see how it goes. We're gonna graph. There we go. All right. So we're gonna sketch the graph. So we're gonna gather information about this so we could sketch the graph. So I'm gonna look for a vertical. Wow, this is worse than last time. Is my pencil dead? What's happening? Okay, we're back. So we have a vertical asymptote. Remember, we find that by looking at the denominator and asking ourselves, what makes the denominator, which is x, equal 0? And then we solve it. In this case, it's already solved. And that's the vertical asymptote, x equals 0. That's a vertical line right here. Okay. And then we check for a horizontal asymptote. Now, we probably should know that the most basic ones, like just something over x, has a horizontal asymptote at y equals 0. But if we forget, we can check with Bobo, who says that if the degree is bigger on bottom, then the asymptote is at y equals 0. Bigger on bottom, 0. So the degree of the top is 0, the degree of the bottom is 1. Remember, degree is the biggest exponent on a variable that you have. So that's that. That's right here. Boop, 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 boop. Do, 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 do. Okay. And then lastly, I mean, we know this because we've seen this. When we get close to our asymptote, our function goes forever. When we get close to a vertical asymptote, it either goes up forever or down forever because it's going to approach that asymptote. And if you're just wondering, how do I know where exactly it is? I say do a quick table if you're not sure. So do a quick like XY and put in something like, put in a positive number like 2. And so 2 would give you 2 divided by 2, which is 1. So 2, 1 is a point. That right there tells me that I'm going to approach this asymptote this way because I'm up. I can't go through this asymptote, so I can't go that way. And then I'm going to approach this asymptote this way, and that's the curve. All right? So just finding one table value can tell you where to draw the curve right there. So that's, now I know what's happening on the positive side. It's up there. But I'm not sure what's happening on the negative side. So I can also try a negative number, maybe negative 2. And 2 divided by negative 2, well, that's negative 1. So negative 2, negative 1 is a point on the graph, which then tells me the second curve is here. So this is the function. You guys, I don't want any confusion about this. The asymptotes are lines that our graph does not touch. They're not technically part of the graph, okay? So the graph is actually just this portion right here, just so you know. But it's definitely very helpful to draw asymptotes. Okay, that's that sketch. And then now they want me to sketch 2 over x plus 3. Well, this is exactly what I just sketched, except that it has moved up 3. Okay, remember your transformations. So my vertical asymptote was right here. And I can move it up 3 if I want to, but it's already going up infinitely and down infinitely, so that's just like a waste of time, okay? Moving this thing up or down is nothing. So I still have a vertical asymptote at x equals 0. Now, I did have a horizontal asymptote right here at 0, y equals 0. And if my function moves up 3, this asymptote's coming with it. So the horizontal asymptote will go 1, 2, 3 up and end up right there. At y equals, oh no, not 0 anymore. It went up to 3, so y equals 3, all right? And then the curve, the graph, they all just got up and moved up 3. So here, let me graph it in a different color this time, green. Boop. And boop. Now you guys, I know it's not perfect. My graph is not perfect at all. Okay? The points aren't going through exactly the places that they should. Okay, like we know 2, 1 is a point. Well, if 2, 1 moved up 3, it would be at 1, 2, 3 right there. And I kind of missed the mark a little bit, didn't I? We don't stress about it like that. Make sure you know where the asymptotes are. Make sure you've graphed it in the correct place. Make sure you're not touching your asymptotes. But the little details of where exactly it goes through, they said sketch. So that part is okay. A little bit of differences there is okay. All right, we're still sketching. We're still sketching. Let's see here. Let's check for our verb. Okay, I'm going to start calling vertical asymptotes VA and horizontal asymptotes HA. I've got myself a vertical asymptote. What? Check it out. It's wherever x plus 3 equals 0. So if you can easily identify that as x equals -3, glorious, good for you. If you cannot, don't worry, just solve. Write whatever's in the denominator equals to 0 and solve it. Plus 3 means -3 on both sides, and I get x equals -3. That's my vertical asymptote. And my horizontal asymptote, I must talk to Bobo button. Bobo says if the degree is bigger on the bottom, then it's y equals 0. And my degree is bigger on the bottom because it's 0, the degree of the top, and it's 1, the degree of the bottom. It's the highest exponent on an x. Over here, this must be an x to the 0 because there's no x there. And this is an x to the first power. So I draw these asymptotes at x equals 3 and at y equals 0. And then I just need to know where these curves are. So you may be able to tell that this is positive, and all of our positive ones have look like this and like this. Okay, but if you can't tell, no problem. Just make a really, really quick table, okay? Plug in something on the right side. So don't just plug in like 1 and -1. That's not going to be helpful. Plug in something on the right side of the asymptote, maybe 5. See what you get? Plug in something on the left side of the asymptote, maybe, I don't know. Should we go with, I don't know why I'm being so picky about it. How about -2? I'm sorry, how about 2? Okay, so let's do it. If I plug 5 in for x, I get 2 divided by 5 plus 3. And 2 divided by 5 plus 3 is 2 divided by 8, which is 1/4. It's positive, which means the curve should be up. So it should have been like this, but still close enough. Okay, remember it's just a sketch, so it doesn't have to be perfect. The key is that it's in the right little enclosed region of the asymptote, which it is. And then at 2, okay, so this was a 4th. At 2, I plug in 2 for x. I get 2 divided by 2 plus 3. Oh, shoot. Oh my gosh, I've made a mistake this whole time, you guys. I drew this vertical asymptote at +3 when it should have been drawn at -3. Like, we found it to be -3, and then I just graphed it wrong. So I am so sorry. That explains why that was so much lower than I expected it to be. Okay, here we go. Watch. -3. It's just minor adjustment. And 0. Okay. And again, I know this to be like like there and here, just because it's positive. And I've seen enough of these to know that the positive ones are here and here, and the negative ones are here and here. But now looking at our table, 5 1/4 makes a lot more sense than how I had graphed it before. And then 2 is no longer a good choice because we need something to the left of our asymptote. And so we need something like -5. And if I plug in -5 in for x, I get 2 divided by -5 plus 3, which is -2. And that gives me -1, which means that at -5, I'm going through -1. And this confirms for me that my curves are in the correct positions. Okay, last one. Last one of the sketches. Let's go. Vertical asymptote is where the denominator, which is x, equals 0. Done. There's my vertical asymptote. Okay, horizontal asymptote is where we talk to Bobo, and Bobo button eats, and DC, where Bobo tells us that if the exponents are the same, divide the coefficients. So over here, the degree of the top, the exponent of the top is 1, the highest one, and the degree of the bottom is also 1. You guys, we only care about the term that gave us the degree. All right? We don't care about any other stuff like this. We don't care about it when it comes to the horizontal asymptote. And so since the exponents are the same, Bobo says DC, divide coefficients. The coefficient of the top is the 2. The coefficient of the bottom is the invisible 1 that's in front of x. So the horizontal asymptote is y equals 2. 2 divided by 1 is 2. So y equals 2 is right here. And again, knowing what I know about these things and them being positive and where their positions are when they are, I'm going to go ahead and sketch my graph like this. But I do encourage you, if you want to see it, or if you feel like you wouldn't know what to do, make a quick table, plug in a value to the right of the vertical asymptote, maybe 2, plug in a value to the left of the vertical asymptote, maybe -2, whatever you want. See what you get and make sure that it matches the positions of the graphs that you picked, of the curves that you picked. Okay, last one. Here's a graph of 4 over x plus 2. A horizontal asymptote there, vertical asymptote here. Write 2 different equations for g of x. Okay, this kind of confuses me a little if I'm being completely honest, because they've graphed a very specific g of x here. So this is the equation of it. I can write equivalent equations, like I can mess with this. I can take 4 over x plus 2, and I can maybe get a common denominator so I can add these, okay? So that would entail me multiplying this by x over x. to get a common denominator of x between them. And then this would become 4 plus 2x over x. So here we go, 4 plus 2x over x. The problem with this is, you guys, is that it's not different. This is the same equation in a different form. So I'm a little bit unsure. Is that what they mean? Or do they mean to write another equation that has a horizontal asymptote here and a vertical asymptote here? If that's what they want, I can certainly do it. A vertical asymptote at 0 means I have just x on the bottom. And a horizontal asymptote at 2 means that the exponents were the same. But when I divided the coefficients, I got 2 as a vertical asymptote. So 2 divided by 1, for example. And then to make sure that my x's don't just cancel each other out, I can add something to the top of this. 2x plus 1 divided by x. Now, this is a different equation. This is not the same. But then can we technically say it's g of x anymore? Because it's a different equation. So I don't know if you can see where I'm getting really hung up on this problem. But whatever. If you wanted to see it in a different form, here it is. If you wanted to see a completely different equation that has the same asymptotes, that one is the one for you. And finally, the spiral review, you guys, I'm not going to do it. All right, I have factored. I have so many videos on factoring. Go back, find them, study them. But I will tell you this. This is going to be so important in this unit. All right, because I don't know if you've noticed, we've been seeing polynomials in these fractions. And we might be seeing these kinds of polynomials in these fractions. And we might need to know how to factor them so we can figure out where our asymptotes are, okay? So make sure you know how to factor. This one, you could use my factoring video if you don't know how. And for this one, this is a cubic function, but because they gave us a factor, you would want to go and divide. X minus 2 divided into x cubed. And remember, this is x cubed plus 0x squared plus 0x minus 8. So that you can start, you know, doing the division thing. That's a negative 2x squared, but I need a 0x squared, so I must put my own 2x squared in there, blah, blah, blah. And if you don't remember this, go back to the division videos, all right? Okay, you guys. Don't skip these. Do not skip these. They're important. They're going to freshen you your skills up because you're going to need them. All right?